The mole is a concept used in chemistry to count small items that come in large quantities. The mole is very similar to a dozen. So normally you have 1 dozen is equal 12 items, and that is 12 of whatever you want to count. The mole, we have that 1 mole is equal 6.22 times 10 to the 23. So it's a very large number that is used to count atoms or molecules normally. So it will be 1 mole, for example, equals 6.22 times 10 to the 23 atoms, or 6.22 times 10 to the 23 molecules. The number 6.22 times 10 to the 23 is known as Avogadro number. Now, the 1 mole of nitrogen, for example, will be equal to 6.02 times 10 to the 23 nitrogen atoms. We can also count molecules, so we could have that 1 mole of NO2 is equal 6.22 times 10 to the 23 NO2 molecules. So if we know how many atoms are present, for example, we can tell how many moles we have in a certain number of atoms. So say, for example, we have 1.15 times 10 to the 18 atoms of nitrogen. We can then use the mole as a conversion factor. And if you remember, in dimensional analysis, when we have an equality, we can write it as a conversion factor, so as a fraction. So we can use this and place it as 6.02 times 10 to the 23 atoms per 1 mole of nitrogen. And these will be atoms of nitrogen. And that will give us 1.91 times 10 to the negative 6 mole of nitrogen. Or if we know how many moles we have, we can calculate how many atoms we have. So say, for example, we have 0.535 mole of oxygen. We can then multiply this by 6.22 times 10 to the 23 atoms of oxygen divided 1 mole of oxygen, and that will give us 3.22 times 10 to the 23 atoms of oxygen. So do remember that we have 1 mole equals 6.22 times 10 to the 23, and we can write it as a conversion factor, either atoms divided by moles, so moles divided by atom. Always make sure that you put across the unit that you need to cancel out. Moles can be calculated also from the masses. In order to convert a mass into moles, we need a new quantity called molar mass. The molar mass of atoms can be found in the periodic table underneath their symbol. And for example, for nitrogen, we will see that underneath we have 14.01. That number is the molar mass of nitrogen and is expressed in gram per mole as units. This number represents the mass of a mole of nitrogen atoms. So 6.22 times 10 to the 23 nitrogen atoms equal 1 mole of nitrogen will weigh 14.01 grams. So we can write 1 mole of nitrogen equal 14.01 grams, which means we can write this as a conversion factor, 1 mole of nitrogen over 14.01 grams of nitrogen. For a molecule, the molar mass can be easily calculated as the sum of the molar masses that compose the molecule. So for example, NO2 will contain 1 mole of nitrogen that weighs 14.01 grams and 2 mole of oxygen. Each mole of oxygen will weigh 16.00 gram because there are 2 moles I will have to multiply this times 2. Now, if you sum up these two quantities, you're going to obtain the value of the molar mass of NO2, which is 46.01 gram per 1 mole of NO2. Now, the molar mass can be used then to calculate the number of moles from the mass. So, say for example, we have 56.31 grams of nitrogen. In order to convert these to moles, we're going to use the molar mass. And you can see we can use this as a conversion factor. So we can simply multiply this quantity by 1 mole of nitrogen divided 14.01 gram of nitrogen. And this will give us 4.019 mole of nitrogen. Now we can do the same using the for a molecule. So if we had 62.5 grams of NO2, we can multiply this by the conversion factor, which is 1 mole divided 46.0 grams for NO2, and this will give us 1.36 mole of NO2. Once we have obtained the number of moles of one molecule, we can convert that. So for example, we have 1.36 mole of NO2. We can convert this into moles of atoms as well that are within the molecule. The chemical formulas provides us ratio of moles, so more conversion factors. When I write NO2, I mean nitrogen 1, oxygen 2, and these are the ratio of moles that allow me to write conversion factor. So 1 mole of NO2 will contain 1 mole of nitrogen, and 1 mole of NO2 will contain 2 mole of oxygen. So I want to convert 1.36 moles of NO2 into moles of nitrogen. I will just place my conversion factor so that the unit that I want to cancel out is across, so 1 mole of NO2 per 1 mole of nitrogen, and this will give me 1.36 mole of nitrogen. So we can say that 62.5 grams of NO2 contain 1.36 moles of nitrogen. We can then take this number and say 1.36 mole of nitrogen, and we can multiply this by 6.02 times 10 to the 23 atoms of nitrogen divided 1 mole of nitrogen. And this will give us the number of atoms contained in nitrogen atoms contained in 62.5 grams of NO2. We can perform the same calculation for the oxygen, and we notice that there's a 2 here. So 1.36 mole of NO2 will contain, in 1 mole of NO2, we will have 2 mole of oxygen, which will give us 2.72 mole of oxygen. And we can then multiply that 2.72 mole of oxygen times 6.22 times 10 to the 23 oxygen atoms divided 1 mole of oxygen. And this will give us the number of oxygen atoms in 62.5 grams of NO2. So in general, and summing up, we can convert, when we have a mass, we can convert this into mole and then convert into number of atoms or number of molecules. We can never convert directly masses into number of atoms or masses into number of molecules. To go between these two quantities, we need the molar mass of the atom or the molecule. Between these two quantities, we need Na, which stands for Avogadro number. Notice that if you just convert in between masses and moles, you will not use Avogadro number.